Mr. Dipankar Bhattacharya, Country General Manager, India at DB-Aire India Pvt. Limited. He is currently responsible for Dunham-Bush business in India. Coming with mechanical engineering background, Mr. Dipankar also had LEED and IGBC accreditations and is having over 2 decades of HVAC&R industry experience. During his illustrious career, he has worked in organizations like Blue Star in refrigeration, Thermax in absorption cooling and Carrier in air conditioning in multiple roles and locations. Today, Mr. Dipankar will give us a brief view on importance of cooling tower in HVAC systems. So delegates, let's welcome Mr. Dipankar.
My disposition is going to be more on the verbal side, so I'm trying to verbalize, whatever my understandings are for cooling towers as far as HVAC system is concerned. So when we look at a plant room, we know that cooling tower is an important part because the chillers that is generating the chilled water, the heat rejection of the chiller actually happens in the cooling tower. And it is extremely important that we keep the cooling tower in healthy condition. So I will first start with the design, the design interventions that we need to have with the cooling tower for it to operate efficiently and deliver the best results for your plant. So from the design point of view, I think it is extremely important that we select the right cooling tower. So when we do that, what do you mean by the right cooling tower? The right cooling tower is something which gives you very low delta T, which has got minimal losses. So we know there are a few losses that are associated with cooling tower in terms of maybe the level of the hospital loss. When it comes to the design, what is important is that you design a low approach cooling tower. That means, let's say if your wet bulb is, say it's 2080. So are you designing a cooling tower which gives you a condenser water inlet temperature or cooling tower outlet temperature 32 degrees C? Or is it a low approach cooling tower can also deliver, let's say, something like 30 degrees C? So that is very important. I know that there's always some cost implications involved when it comes to, taking cooling tower which is high on design, high on specification, rich on specification. But it is worth the while because whatever additional money you put in buying the right cooling tower, you save, more than that while operating the chiller on the operating costs. So it's very important that you pick up the right cooling tower. So this is one important part because we know that the heat rejection that happens from the condenser, that is taken away by the cooling tower. The condenser water temperature, which is water which is coming from cooling tower and then being rejected in the cooling tower in the atmosphere. And we know that for every 1 degree increase in condenser water entry temperature is coming from cooling, we are looking at the refrigeration capacity lost to the extent of, let's say, 5%, which is a very high number. It may not look significant, but in case you are losing 5 to 7% on account of a cooling tower malfunction, then your efficiency will also go for a toss and it will probably not a very efficient operation over a long period of time. So when you look at the annual power bill, this 5% also is going to, because your power consumption is going to go up, your efficiency capacity is going to be down, so you'll be inefficient in terms of your cooling delivery, you'll be inefficient in terms of your power consumption, and that's not the most desired situation to be in as far as the building operator is concerned. So it's important that we keep, in terms of design intervention, that is one important aspect. So what are some of the modern concepts we have been hearing? I mean, of course, Mr. Ravi is there, who is an expert in cooling tower. He can talk a lot about how the cooling tower can be maintained. It should be kept in a good condition to deliver the best results for the plant. But some of the modern concepts that I get to hear about cooling tower that is kind of becoming a part of design integration when it comes to a plant room is the cooling tower staging, or let's say when we're looking at something like VFD on a cooling tower fan. So what it happens is, whenever there's low load, instead of running the entire, when it's low load, obviously the chiller is operating in part load condition. So you have multiple cells on the cooling tower. You cut off few cells and operate with the rest of the cells to deliver the right kind of service for the cooling tower for the plant room, and that kind of saves your power in terms of whatever power you can save on the fans, on the cooling tower fans. It can also be equipped with a VFD where it can modulate. When it is modulating, obviously you will not exactly have a cutoff and cut-in situation, but we know the benefits of VFD on a rotating equipment. You also get a lot of savings in case you are able to modulate the cooling tower depending on the building load variation across the day, across the season, and through that also you can get a lot of savings. This is probably the component of the plant room which is situated outside and it is exposed to the atmosphere, and it is an open loop system. So all the dust and impurities get settled over there. Eventually that gets carried onto the chiller and gets deposited on the chiller tubes as scale. We know how bad it is for the chiller to have scale, because the moment there is a scale formation, it's an impediment to heat transfer. The capacity drops, the power consumption goes up, and there has to be regular interventions needed to clean those scales to bring the chiller back on its peak capacity, or somewhat closer to its peak capacity. So it is important that this is avoided. So a cooling tower should be maintained in a way where there's less of scale formation. There's chemical dosing is also done in an optimal way. Of course, there's some chemical cleaning that necessarily also mentioned. It's very important that those things are being introduced to keep the cooling tower in absolute healthy condition, to get the optimal or the maximum result from the chiller. Cooling tower per se is not a very energy guzzling equipment, but it is catering to a component and equipment which is an energy guzzling equipment. And the more you facilitate that, more you keep your peripherals in a healthy condition. The chiller, the HVAC plant room, heart of the system is chiller, and if you keep the peripherals in healthy condition, chiller delivers the best performance that is possible. So that is why we consider cooling tower to be an absolute important part of the plant room. It's imperative that we keep that in healthy condition. What has also happened in recent times that when we are looking at the efficiency of the plant room, we are not looking at from the point of view of chiller. We are looking at from the point of view of the entire plant room and all the components that are part of the plant. So the cooling tower, the pump, the chiller, all are part of the plant room, and they are in sync with each other. They're talking to each other, they're communicating with each other. So it's very important that we have a control system in place which facilitates this communication between the components. Because building load keeps varying. It could be an internal load, it could be an external load, because it could be different days, a different time in the day, it could be different season, So all these factors contribute to a lot of part loading that happens. And if you have the right system in place, right control system in place, I think the communication becomes easier, it becomes seamless, and the components can be perfectly in sync to deliver the best efficiency. So these are some of the new trends we are seeing in plant room performance, and that's how cooling towers is important when it comes to the overall plant room chiller delivering the best efficiency. That's all from my side.